Okay, this is grading exercise video 4.5. For this, we are going to grade stairs, cheek walls, and retaining walls. They say to provide all spot elevations and show proposed contours. So, for refresher, cheek wall, when they say cheek walls, they're referring to both sides of the stairs. These are cheek walls that frame both sides of the stairs, and hence that's where they get the name cheek from, cheeks on both sides. So with that, let's go ahead and get started. So the first thing we're going to do is look, these are 1 foot contours, and we know that the top of step here, the elevation is 145, and this dashed line is the top highest point of the step. It's the expansion joint where the top step meets the sidewalk. So that's the information we have. The scale is 1 inch equals 8 feet. So to get started, what we're going to do is just draw the various elements as they've described them here. Once we have those drawn, then we can start grading the problem. So let's just start at the top, and we'll start with the stairs. It says to create 2 flights of stairs with 5 steps each, separated by a 5 foot landing. The riser height is 6 inch, tread is 12 inch. Slope of the stair landing is 2%. Show all parts of the stairs. Label top of step and bottom of step for each set of stairs. So let's just go ahead and start by drawing in those 2 flights of stairs with 5 steps each. This is our starting point, which they gave us. So we need to draw in 5 stairs for this first one, which will be 5 solid lines. So I'll just go 1, 2, 3, 4, 5, and then I'll do 5 more and connect the dots. 1, 2, 3, 4, 5. And I'll draw these in. You see I just marked the dots 1 foot apart because it said that the treads are 12 inches. So we'll just draw these in real quick. 2, 3, 4, 5. So there's the top of the step. So there's the first riser. 1, 2, 3, 4, 5. And then it says separated by a 5 foot landing. So now we've got to draw the 5 foot landing. So come off that bottom step. We go 5 feet. Right, and then now remember, this is going to be a dashed line. This is the top of your step where it meets. This is not actually a riser. This is that expansion joint for this second flight of stairs. So with that, we'll go ahead and draw in 5 more steps. 1, 2, 3, 4, 5. 1, 2, 3, 5. So draw these in real quick. There's 1 step, 2, 3, 4, 5. So now we have two flights of stairs with 5 steps each, and a 5 foot landing in between, and then down at the bottom here we have 2 more feet. So that's drawn in. So next, and then what's it say? It says this. Let's go ahead and write this in. Slope of stair landing is 2%. So we'll just draw in 2%. That's just what they're giving us. And then riser, slope of stairs, show all parts of the stairs, label. Okay, so that's that. Now, what we could do is go ahead and draw in our railings. That way we won't forget our railings. And our railings, we can just come in on each side. These stairs are, looks like it's 5 feet, so we will just draw railings on both sides of the steps. Here, and then another set here. And I'm just coming in. They could be mounted on the sides of the cheek walls, or because anyway, we're not really designating how the rails are mounted, we're just showing them. So I'm going to draw, let's see, we're going to have, so we're going to go down here about a foot. Just going to do this. So start up here, come down, start here, come down. So what you'll notice I did was, we have to remember that extension at the top. We have to have the railing has to go a foot above the top of the stairs, or the top riser, and then also has to extend a foot beyond the bottom riser. So we'll draw those in on both sides. So like that, and like that. Okay, so now we've got the stairs drawn in. Let's go ahead and do the cheek walls, which is next. Cheek walls are 1 foot wide and continuous. Cheek walls extend horizontally 1 foot above and 2 feet below the stairs. So here's the bottom step. There's 1, 2, so 2 feet takes you right to the corner here. And then 1 foot above, so here's the top step. So basically, the cheek wall goes to the edge of the expansion joint. It's kind of a little confusing here because they say 1 foot horizontally, cheek walls extend 1 foot horizontally above the stairs. I could see people interpreting that as another foot beyond this expansion joint, but in the book they just go to the expansion joint, so that's what we'll do. So I'm going to draw in, it's a foot wide on both sides, so we're just going to draw it on both sides. Like this, draw it parallel, so it comes down like this, then down this side. That's about right there. And then it closes at the top here, just goes right in line with that expansion joint. And then cheek walls extend. Top of cheek walls 2.5 feet higher than the first top step, bottom step. That we can do when we're grading. So there we've got our cheek walls. Let's draw on our retaining walls. They're a foot wide and extend 14 feet on both sides. So with that, we'll do 1 foot wide retaining wall, and it's going to extend 14 feet each direction. 12, 13, there's 14 feet goes to there, and then 14 feet goes to here. Let's draw this in, that down to there, there. Close this off. So there's your 2 cheek walls, there's your 2 retaining walls, and they extend 14 feet both directions, which is what they say right here on the retaining walls. Bottom cheek 1 foot wide retaining walls extend perpendicular to the bottom of the cheek walls for 14 feet on both sides. So now that we've got it all drawn, we can start grading. So the first thing we need to do is determine the top and bottom elevation of our steps. So let's do that. We know that we've got 1, 2, 3, 4, 5 risers, and they're 6 inches. So we know that these steps drop 2.5 feet. So you just take this 145, and you subtract 2.5 feet, and you get at the bottom of the steps. So you do bottom of step 145, 145.5. I'm going to write it over. So I'll write it over here just so you can see it. So bottom of step equals 145.5. It's kind of hard to read that, but that's what that says, 145.5. And then now we've got to go at 5 feet, which is the length of this landing, it's 5 feet at 2%. So we've got to go 5. We're determining the vertical, right? The vertical drop from here to here, and vertical, write it over here. Vertical equals horizontal times slope. So vertical, horizontal, we set was 5 feet from there to there. And the slope is 2%. So it's 5 times 0.02. And that equals, let's see, how did I miss? I don't want to put my calculator. Had it earlier. Oh, here it is. So 5 times 0.02 equals 0.1. 0.1. So the top of step here, we have to take this 145.5 and we have to subtract 0.1 and we get 142.4 for the top of step. And it's a little tight in there for me to write that. So I'm going to write top of stairs 145.4. Okay? Or 142.4. 145, that should be 140. Oh man, I've been saying that incorrectly and you're probably all confused. That is one, from here it's one, this is 145, you take 2.5 feet, that's 142.5. I was saying that wrong. Hopefully you stuck with this video long enough to get the right answer here. And then this is 142.4. So we took 145, came down 5 steps or 2.5 feet because they're each 6 inches. That gives us 142.5. Then we went 5 feet at 2%, so 5 feet times 0.02, so that gave us 0.1. We subtract 0.1 from 142.5. That gave us the top of stairs here of 142.4. Now we've got to go 1, 2, 3, 4, 5 more steps, which is 2.5 feet. And we've got to subtract 2.5 feet from 142.4. 142.4 minus 2.5, 139.9. So the bottom of step, I'm just going to write 139.9. Tight on space here, so I'm not going to write B bottom of step, but I'll write it right over here. Bottom of step equals 139.9. Elevation there. So we've got our stairs. Now we've got to do these cheek walls. So they say the cheek walls are 1 foot wide, 1 foot above, and 1 foot above, 2 foot below the stairs. Okay, top of cheek walls are 2.5 feet higher than top of step and bottom of step. So bottom of step is 139.9. So we got to add 2.5 feet to that. And what we're doing is we're getting the top of wall here and the top of wall here. It's the same on both sides. So 139.9, we just add 2.5 feet and we get top of wall of hang on here, 139.9, 139.9, and we're going to add 2.5 feet plus 2.5, 139.9, 142.4. So the top of wall here is, I'm going to write right here, 142.4 feet. That's the top of wall. That's top of wall. And same thing over here, top of wall. 142.4, 142.4. So now we've got the top of wall here and here. Let's do the same thing up here. This is 145. We got to add 2.5 feet to the top of wall, top of the step, and that gives us 147.5. So we take 145 plus the 2.5 feet, which is the height of the cheek wall right there, and that gives us top of wall 147.5. So, and same thing on this side over here. Top of wall, 147.5. Now, bottom of wall and bottom of wall. For up here, in the instructions here it says, bottom of wall at the landscape side of the cheek wall is 3 inches lower than top of wall. So 3 inches, if you go 3 inches is the same as 3 divided by, or 3 divided by 12. So 3 inches is the same as, if you go 3 inches divided by 12, because there's 12 inches in a foot, equals 0.25 feet. So a quarter foot. So 0.25. So we've got to subtract, this is the same thing as 3 inches. So we got to subtract 0.25 from the top of wall on both sides. And that gives us, if we go 147.5 minus 0.25, that equals 147.25 on both sides. So right over here, 147.25 on both sides. 147.25 and 147.25. Here it's 142.4 is the top of wall. We've got to subtract 3 inches from that as well on both sides, because here on the retaining wall it says same thing. Back of wall, or bottom of wall at the back of the retaining wall is 3 inches lower than top of wall. So this top of wall, we got to subtract the 3 inches, which is 0.25. So 142.4 minus 0.25 equals 142.15. So bottom of wall on this side is 142.15. So bottom of wall here, 142.15. Bottom of wall on this side, same thing, 142. Bottom of wall, 142.15. So both sides, the bottom, all I did, that's this elevation right here, all we did was take the top of wall, and we just calculated and took 3 inches from that, which is 0.25 feet. A quarter of a foot is the same as 3 inches, and that's where we got 142.15. Next, let's do the bottom of wall on this side. So we need to know what, at this corner, what the bottom of the wall is. And it's going to be the same on both sides, because this at the bottom of the steps is just going at 2% out to the sidewalk here. Same as the landing, it's 2% here, and then the sidewalk probably has a 2% slope, but we're not going to grade that. We're just doing to this corner right here. So it's 2 feet. If you measure this with a scale, you'll see that it's 2 feet from the bottom of the step to the corner. 2 feet at 2%. So 2 feet times 0.02 equals 0.04. Add that to 140, or not add, subtract that from 139.9. 139.9 minus 0.04, 139.86. So your bottom of wall, 139.86, bottom of wall. So your elevation at both corners is the same, 139.86. We just took 2 feet at 2% and subtracted it from that elevation of the bottom step. So now we've got all our spot elevations. All we have to do now is finish our contours. I'm just going to do this side over here because this side is exactly the same, right? Because the elevation 147.5, bottom of wall 142.15, same exact thing over here. So I'll show you how to do it on this side, and you can do it the same on the other side. Remember, we're going to interpolate now. So the bottom of wall Let's write this down. Bottom of wall up here is 147. Oops. 147. 147.25. 147.25. That's the bottom of wall. Bottom of wall here is 142.15. So 142.15. What does that equal? Let's see here. 147.25 minus 142.15 equals 5.1. 5.1 feet. So on the outside of the wall here on the grade, it drops 5.1 feet from here to here. So that means we're going to have, if this is 147.25, we're going to find the next whole contour going downhill, right? 144, 43, 42 is going downhill. So if this is 147.25 going downhill, we're going to find whole contour 147. To do that, we have to know what the slope is. We know the horizontal distance just by scaling it. So let's do that real quick. Horizontal distance is 16 feet. From here to here, it's 16 feet. So horizontal equals 16 feet, and our vertical is 5.1 feet. Vertical equals 5.1 feet. We got that just from subtracting this elevation from this elevation. Bottom of wall here from bottom of wall there. So with that, where is slope? Did we write down? Slope equals vertical divided by horizontal. So vertical 5.1 divided by horizontal 16 equals 5.1 divided by 16 equals 0.3185. So you get 0.31875. So we can just round to the nearest to the hundredth. So this would be the same as 0.32 or 3.2%. See that? We just are rounding to the nearest hundredth. So since we know that's 3.2%, or not 3.2%, it's 32%. Because this is, there's no zero, it's 0.31, so it's 31.9%. Or 88, either way, 31.9%. 0.31875 is the same as 31.9%, or 30, you could say 31.88%. Either way, you're very close. Either way, we can, it'll work either way. So with 31.9% being our slope here, now we know we need to drop 0.25 feet from 147.25. We got to get to the nearest whole contour going downhill, which is 147. So 0.25. So we're trying to find the horizontal distance from this corner to that contour. So the horizontal distance we don't know, but it equals vertical divided by slope. So the vertical is 0.25 to get from 147.25 down to 147. So 0.25. Divide that by the slope, which we said was 0.319. Okay, 319. So let's do that math, and that equals 0.25 divided by 0.319. 0.319 equals 7 point, let's see, this math, 0.25 divided by 0.319 equals 0.78. 0.78. So about 3/4 of a foot, right? 0.78 is the same as about, it's not 1 foot, it's about 0.75. So on your scale here, you're going to just measure 0.75, put you right about here, and put a mark right there. That's contour 147. So that's that one. Let's go ahead and do the rest of them. So now to go to 147 to 146, that's a 1 foot drop. So now we go 1 foot divided by 0.319, right? Because that's the slope. That's the horizontal, or the vertical drop is a foot. So 1 divided by 0.319, 3.13 feet. So now just go slightly over 3 feet. So 1, 2, 3, slightly over, and put a mark. That would be 146. Go another 3 feet, just slightly over. Another mark, another 3 feet. So every just slightly over 3 feet, we're putting a mark. So there we go. So I put marks every 3.13 feet. So now we've got 147, 146, 145, 144, 143. And then this is 142.15 at the bottom. So there's no 142, right? Because it's this elevation of the bottom of the wall is above 142. So 142 is going to fall along the back of your retaining wall. And the retaining wall, they say, top of retaining wall slopes at 2% for 14 feet on either side. So this is sloping 2%, says it right there. 2% this way. So this is 142.15, so our vertical to get to 142 from 142.15, we have to subtract 0.15 feet. That's our vertical. So horizontal is vertical, 0.15, divided by our slope, which is 0.02 because they give it to us right there. What's that equal? 0.15 divided by 0.02 equals 7.5 feet. 7.5 feet. So contour 142 is 7.5 feet from this corner going this direction. So we'll just measure that. Put 4, 5, 6, 7 right there. Now it's going to be the same thing this way. It's going to be 7 feet, 7.5 feet going this direction. It's going at 2% sloping this way. This is going 2% this way, 2% that way. So all your contours over here are going to be the exact same, straight across, because it's the same exact elevations. So you can tie in the same exact way over here that we do on this side. And I'll show you real quick how that's done. This is 147. I'm going to do it in red pen so you can see it. It'll be easier. So this is 147. 147 is clear up here. So it ties in like this. This is 147. Okay. And then 146 is right here. Ties in like this. That's 146. 145 ties in. Come on, pin. 145. 140, 45. So 147, 6, 45. And next is 144. The pin is not cooperating. This is 144, 144. Try another pin. That one's going dry. And then 143 ties in here. Yeah. So this is 143. So see how we're just tying back into the contours? And for the cross maximum landscape slope, see here, proposed contour 3:1. So you just have to make sure our contours stay 3 feet apart. So they would be 3:1 max. Right? So if you write that in, Even if it's not exact, if you write that on the slope, we'll know that you knew what you were doing. So then this is 142. 142 just has to tie in right there. So 142. So you would do the same thing over here. On this side, it's going to look exactly the same. You're going to come, you know, this will come straight across like so. That contour and ties into 147 here, like that. So 147 and so on all the way down, just like you did on this side, you do on the opposite, and that's how you do it. One of the problems that you'll catch in this class, or in this grading problem that we talked about in class, is there's a bit of a blow and grade. This is top of step, see that's 145, and then bottom of wall is 147.25 right there at that corner. That means there's almost 2.5 feet from here to this corner, and so you would either need to extend this wall to fix that, or add additional steps, and that would get this up higher to tie in closer to that grade of the soil, which is 147.25. So anyway, in some of my classes, the students have noticed that blow and grade. It's not a part of this problem. It's something we could fix, but this solves this problem. So don't worry too much about that blow and grade right there. Just know that you could, with some extra steps or additional wall, we could fix that difference in elevation pretty easily.